2 minus 2. It's so simple a child can do it. But for most of human history, the answer to that equation was not obvious. It was impossible. It was even considered the work of the devil. We take it for granted. This simple circle, a symbol for nothing. We use it hundreds of times a day. It's the beating heart of every computer, every smartphone, every modern machine of war and peace. But that tiny, innocent-looking zero has a terrifying past. It's a forbidden idea that was suppressed, banned, and condemned for centuries. So, why was nothing so dangerous? Why did ancient empires need it but refuse to accept it? In the next few minutes, we're going to travel through 5,000 years of history to uncover the story of zero. It's a story of mathematical genius and mystical thought, of commerce and cosmic belief. But more than anything, it's a story about the human mind's terrifying and beautiful ability to conceive of the infinite and the void. One could say it's not just the history of a number, it's the secret history of nothing, and how it created everything you see around you. Let's start at the beginning. Our journey begins not with a number, but with a problem. Problem of accounting. Over 5,000 years ago, in the Fertile Crescent, the Sumerians created the world's first great civilization. They invented the wheel, law, and writing. And, according to Robert Kaplan, author of The Nothing That Is, A Natural History of Zero, they developed a sophisticated positional number system. This was a system where the value of a symbol depended on its position, just like ours today. But what happens when you need to write the number 102? How do you show that it's not 12? According to Scientific American, the Sumerians came up with a solution. A placeholder. A slanted double wedge, some 5,000 years ago. This wasn't a number. It was just a punctuation mark, a breath, to prevent a scribal catastrophe. It was the difference between 26 and 206, between a moderate harvest and a disastrous miscalculation for the king. This idea was passed to the Akkadians and eventually perfected by the Babylonians, masters of astronomy. They had a base 60 system, which is why we still have 60 seconds in a minute and 360 degrees in a circle. But according to Charles Cipher, author of Zero, the biography of a dangerous idea, the first real placeholder zero was born in Babylon between 400 and 300 BC. It was a way to tell 1 from 10 from 100. However, and this is the crucial point, if you asked a Babylonian thinker, what exists? They could point to a goat, a jar of oil, or a star. But if you asked, what is the number of the wind, of emptiness? The idea was simply absurd. Their zero was a servant, not a citizen of the Republic of Numbers. It wasn't something you did calculations with. It wasn't a number. It was just a handy tool. And for a true number to be born, we have to travel 12,000 miles and 600 years into the future to another civilization that dared to confront the void. Cut off from the old world, the Maya civilization independently conjured one of the most sophisticated mathematical systems in human history. They needed it not for counting sheep, but for measuring time itself. The Maya were obsessed with cycles of time, cosmic calendars that tracked the past and predicted the future for millions of years. And here, around 350 AD, they invented their own zero. They represented it as a shell-shaped glyph, which they called Nick. Unlike the Babylonian placeholder, the Maya zero had a deeply philosophical meaning. According to the American Astronomical Society, Nick was not just an absence. It implied a bridge between the past and the future, a symbol of both the beginning and the end. It was a sacred concept, linked to their gods and the cycles of death and rebirth. The oldest known representation of this Mesoamerican zero, dating from 31 BCE, is found on a stone carving in the ancestral Olmec site of Tres Zapotes. The Maya used a base 20 system, and to write the number 403, for example, a Maya would use a symbol for 1 unit of 400, a shell for 0 units of 20, and 3 dots for 3. The zero was essential. Yet, as sophisticated as it was, the Maya zero remained isolated. When their classical civilization collapsed, this incredible mathematical insight was swallowed by the jungle, with no direct lineage to the zero we use today. For that, our story must pivot, again, to a civilization that had been pondering the void for centuries in a very different way. The question was no longer, how do we mark an empty space? But, what is emptiness itself? In ancient India, a radical philosophical concept had taken hold. Shunyata, the void, emptiness. It wasn't just a blank space, it was a profound state of being. Central to Buddhist and Hindu thought, Philosophers like Nagarjuna, as early as the 2nd century CE, expounded on emptiness as a fundamental nature of reality. According to the Diplo Foundation's Journey of Zero, this cultural and spiritual environment was crucial. It was the perfect intellectual soil for the seed of a true number to be planted. Physical evidence of this evolution was discovered in 1881, when a farmer unearthed a mathematical text called the Bakshali manuscript. Etched on 70 leaves of birch bark are hundreds of dots, used to denote zeros. According to research published by the University of Oxford, carbon dating of this manuscript revealed that some of its pages were inscribed between 224 AD and 383 AD, pushing the known history of this zero symbol back by 500 years. At this stage, it was mostly used as a placeholder, but the evolution had begun. As Professor Marcus du Sautoy noted, the creation of zero as a number in its own right, which evolved from the placeholder dot symbol found in the Bakshali manuscript, was one of the greatest breakthroughs in the history of mathematics. And then, in the 7th century, came the masterstroke. According to a biography by Britannica, the astronomer and mathematician Brahmagupta, in 628 AD, wrote the first ever text describing zero as a true number with rules for arithmetic. He gave zero its birth certificate. He defined it. In his text Brahmasfuta, he wrote rules that seem so simple to us today, but were revolutionary at the time. A number plus zero remains unchanged. A number multiplied by zero becomes zero. This was the moment. Zero was no longer a passive placeholder. It was an active number that could be used in calculations. He wrestled with division by zero, a problem that still plagues mathematicians, but his framework was the Big Bang of modern mathematics. As British mathematician Vicky Neal explained, this is where we see zero change from placeholder to number. For the first time, someone set out the role of zero as a number. His depth of mathematical insight was extraordinary. As the flame of knowledge began to dim in Europe during the Dark Ages, the torch was passed to the Islamic world. During the Golden Age of Islam, a massive translation movement was underway in Baghdad's legendary House of Wisdom. Scholars from across the caliphate were gathering and translating the world's knowledge, and they quickly recognized the power of the Indian system. The master mathematician Al-Khwarizmi was instrumental here. He translated the Indian Shuanya into Arabic as cipher, meaning empty or nothing. According to the Diplo Foundation, this is the root of our English words cipher and zero. Al-Khwarizmi's treatises systematized the use of these Hindu-Arabic numerals and their arithmetic. This was computing powerful, fast, and elegant centuries before a machine could do it. The system spread across the Islamic world. Arab merchants used it to perform complex commercial calculations with ease, turning mathematics into a competitive advantage. And it was this commercial and intellectual powerhouse that was about to knock on Europe's door, which was still locked in the cumbersome world of Roman numerals. The number zero, now called Zephyrum or Zephiro, was about to cause a scandal. In the 13th century, Europe was calculating everything using Roman numerals. Try doing long division with MCMXXXVIII divided by XXIV. It's a nightmare. But the greatest barrier was not mathematical, but theological. For the medieval church, zero represented the void, a concept that was deeply troubling. According to author Robert Kaplan, zero was controversial to the church because it was thought of as devil's work. It was the antithesis of God, a symbol of a godless emptiness before divine creation. The very word naughty is descended from not. To be nothing was to be bad. The ancient Greek philosopher Aristotle had also rejected the idea of a void, and his philosophy was deeply embedded in church dogma, reinforcing a terror of the void. Enter our hero, a young Italian man named Leonardo of Pisa, whom we know today as Fibonacci. The son of a merchant, he grew up in North Africa, where he witnessed the power of the Hindu-Arabic system firsthand. In 1202, he published Liber Abaci, the Book of Calculation, arguing passionately that merchants and bankers should abandon Roman numerals for this new system. As he explained in his book, these methods made complex calculations very rapid, and he even dedicated an entire chapter to commercial problems. Fibonacci's system was a revolution in commerce. However, the path was not smooth. The establishment pushed back. In Florence, the city of banking, the use of these new Arabic numerals was even banned in accounting, judged as obscure and too easy to fraudulently manipulate. Zero was a profound epistemological threat, but you cannot suppress a mathematical truth. The efficiency was undeniable. Over several hundred years, as Kaplan notes, Zero becomes a naturalized citizen through the work of merchants and accountants. By the Renaissance, the battle was over and zero had won. And now that nothing was a fully naturalized citizen of Western thought, it was about to detonate a scientific revolution. The introduction of zero and the decimal system didn't just change mathematics. It unlocked an entirely new universe. It gave birth to negative numbers, allowing us to see zero as a true center, a origin point. It paved the way for algebra to become abstract, for physicists to conceptualize concepts like the vacuum, and for the entire field of accounting to be revolutionized. One could say it made the financial and scientific infrastructure of the modern world possible. But the most profound bang from the zero was yet to come. In the 17th century, Isaac Newton and Gottfried Leibniz independently developed calculus, a new form of mathematics that could describe motion and change. As Vicky Neal explains, calculus allows us to make sense of dividing by smaller and smaller numbers, and is fundamental to understanding the world around us. Without it, we wouldn't have made breakthroughs in physics, biology, and economics. Calculus is the mathematics of approaching zero, of dividing time and space into infinitely small slices. Without zero as a functional concept, calculus is literally unthinkable. And without calculus, there is no understanding of gravity, the orbits of planets, the laws of thermodynamics, or how to build a steam engine. The industrial and scientific revolutions were built on this nothing. Zero had gone from a feared heresy to the cornerstone of reality. And then, zero underwent its final, most transcendent transformation. In 1948, mathematician Claude Shannon developed a mathematical theory of communication that relied on a simple binary digit, or bit, that could be 0 or 1. This was the conceptual seed of the entire digital age. Everything you see on a screen, this video, the digital world, the entire internet, is at its most fundamental level, a string of zeros and ones being decoded by your device many times per second. Zero is no longer just a number. It is the universal language of information. It is the silent electron that is either charged or not charged, the magnetic spot on a hard drive, the light pulse in a fiber optic cable. Without zero, there is no binary code. There is no computer. As the BBC puts it, without that binary code in zero, this video you're watching wouldn't exist, and nor would the world as we know it today. From a terrified wedge on a Babylonian tablet, to a sacred shell in a Mayan temple, to a revolutionary in a Hindu-Buddhist text, to a forbidden digit that scandalized the medieval church, the zero's journey is humanity's journey. It is the story of our struggle to confront nothingness and create everything. It's a testament to the fact that the most powerful ideas in human history are often not the things, but the relationships between them. The concept that would seem to signify a complete lack of content is, paradoxically, the very seed of infinite potential. And that's just a thought to leave you with. If you enjoyed this journey from nothing to everything, make sure to hit that like button. It's the easiest way to support the channel and helps us bring more untold stories to light. Subscribe and ring the bell so you don't miss our next deep dive. Now over to you. What dangerous idea or forgotten piece of history should we explore next? Tell me in the comments below. Until next time, stay curious.